Okay, in this video we're going to look at an introduction to solving equations with radicals in them. And so one of the rules in mathematics is that if we square both sides of a given equality, okay, that the resultants, okay, the solutions to the original will also be solutions to what shows up. So here's what I mean. If I have something, let me give you an example, and then we'll work on these guys above. Let's say we had something like the square root of a number is equal to, I don't know, 2. Now the question is, what number can we plug in there? Well, if we square both sides, we don't lose our solutions. Okay, in fact, our solution is still in here. So watch. When I square both sides, I get this, and so I get x is equal to 4. Now we know that to check, that the square root of 4 is equal to the following. And clearly the square root of 4 is 2. So it does check out that if we take the square root of 4, we get 2. But here's the problem with it. Let's say we had the square root of x is equal to negative 2. Now we know there's no solution to this because we can't take the square root of any real number and get a negative value. But when we square both sides, we again get this. And negative 2 squared is 4, and so we get x equals 4. Now the problem with this is that we have a solution, extraneous solution, that has occurred that wasn't an original solution. So what happens is when we square both sides, we'll always get out our, if there was, so let me write it down like this. If there was like an original solution, so if we'll get it out at the end, right? So if there was an original solution, we'll get it out. However, we may get extra solutions that don't really work. And so we have to be careful because we could get guys like this out here. So what we do is we go and we check at the very end to make sure that our solutions do work. Now it's very easy to see in the beginning, and when the problems get harder, it'll be more difficult. So here's what we're going to do. We're going to work on these two problems right here, and we're going to solve them by squaring and knowing that we're not going to lose our solutions, but we might gain additional solutions that aren't actually solutions. They're like fake solutions, okay? So let's square both sides. So when we square both sides of this, okay, I get 3x plus 19 is equal to 25. Now I solve this like I would any ordinary equation. So we'll subtract 19 from both sides. And we'll get 6 on the right side, 3x on the left side, divide both sides by 3, and we'll get 2. Now, because we squared, in the solving process, we need to check. So what we're going to do is we're going to take our 2 and we're going to plug it into the original. It always has to go back into the original, not into anything after the squaring, because if you do it after the squaring, well, you're going to end up seeing that that solution works. Okay, so we need to put it into the original. So this will be 3 times 2 plus 19. So that's the square root of 6 plus 19, which is the square root of 25, which gives us 5 out. that's what we were looking for. Now here, I've got the square root of something is equal to -4. Now we know that that's not possible, but watch what happens, because this is what most students do. They blindly attack the problem. They say, oh, well, I'll just square both sides. And we can do that. We can square both sides. There's not a problem there. If I square both sides, I get 2x plus 2 is equal to -4 times -4, which is positive 16. Let me again explain why that is. It's -4 squared, and -4 squared is, by definition, -4 times -4. Negative times a negative is a positive 16. Subtract 2 from both sides. Divide by 2. We get a value of 7 out. But again, because we squared, we need to check. So our check would be the square root of 2 times 7 plus 2. That's equal to the square root of 14 plus 2, which is the square root of 16, which is positive 4. But that's not equal to -4. So this guy is not a solution. And since I only had one solution and now I ran out, the answer for this is no real solution. Whereas the answer to this is that x is equal to 2. So this guy has a solution. This guy over here, this equation right here, does not.